Hello friends, good morning everybody. Today I am starting new unit. The name of the unit is Organic Synthesis via Unilates. This unit from chemistry paper number 1. See in this unit, the first point is active methylene compound. Here methylene means CH2 group. CH4 group is a methane and CH3 group is a methyl and CH2 group is the methylene compound. This methylene group is make active due to the presence of electron withdrawing group is directly attached to this methylene group. Here is two groups electron withdrawing group is directly attached to both sides, this side and this side, and this is a became a active. See the example of active methylene compound. Here CH3 C double bond O, CH2 C double bond O, C2H5. The name of this compound is ethyl acetoacetate. Here is CH3 C double bond O. Here is this C double bond O, C2H5 is the electron withdrawing group. This is the acidic group, carbonyl group, or nitro group, or cyano group. Electron withdrawing group is attached to this methyl. This becomes a active. Here is the CH3 C double bond O means the carbonyl group. It may be aldehydic or ketonic group. This side is a C double bond O, C2H5 is the ester group is attached to this methylene. It becomes a active. It is a active or acidic character. This shows the acidic character. Here is see the another example is C2H5O C double bond O CH2 C double bond O C2H5. The name of this compound is diethyl. Here is C2H5 and here is the C2H5 means diethyl malonate compound. These are electron withdrawing group and these are the another electron withdrawing group is attached to this methylene group. It becomes a active methylene group. See the another example here, electron another group is attached to here, cyano group. C triple bond N means cyanide is attached to here this CH2 group, and here is the uh, C2H5 C double bond O. This is the compound is ethyl cyanoacetate. See another example here, C2H5O C double bond O CH2 N double bond O. Here is single bond O. This is the nitro group. This nitro group is also electron withdrawing group. This methylene group is attached to electron withdrawing group. It becomes a active. See the next point here, ketoenol form. Ketoenol form is one of the form is keto and another form is the enol functional group. See here example, here is the CH3 C double bond CH2 C double bond O CH3. Here is C double bond O. Here is the C double bond O means carbonyl group, or this carbonyl group is attached both sides CH3 CH3 means this is the functional group is ketone or keto. Here is same C double bond O CH2. Here is the CH3 group is attached means this carbonyl group both sides is attached. The carbon is a ketonic group. If here is attached the hydrogen or here is the attached the hydrogen, this functional group is a aldehyde group. But here is the both side is attached to CH3 group. Here is that is the C means carbon carbon is attached both side is at the carbonyl group. It becomes a ketone. Or here at equilibrium position, this hydrogen is abstract or attached to this oxygen, and this hydrogen is attack bond here formation of double bond, and here is double bond O is a formation of the single bond. See here OH is formation of the single bond and here is the formation of double bond, carbon carbon double bond. Here ENOL means first one En means here is the carbon carbon double bond is present means here is the alkene, and here is the OH group is present means here is the alcohol. So its formation or name is a ENOL or enol form. Here is carbon carbon double bond means En and OH group means the alcohol OL is used here. So this formation is called as the enol form. Here is the CH3, COH, C double bond, CH, C double bond actually here, and CH3. The name of this compound is acetyl acetone. Acetyl acetone. These are here CH3 and here is the CH3. Means this is the symmetric compound. See the next another example is CH3 C double bond O CH2 C double bond O C2H5. Here is carbonyl group is attached both side. Carbon is a ketone form. Here is also C double bond O C2H5. Here is that as the carbon. So it is a ketone form. The same here. Carbon-carbon double bond is present means this hydrogen is attached to this oxygen and here is formation of carbon-carbon double bond and this carbon oxygen convert into single bond and here is the presence of hydroxyl group. It is the alcohol, so it is used as a OL and here is presence of the carbon-carbon double bond. It is written as the EN. So it is a enol form. The name of this compound is ethyl acetoacetate. Here is the ethyl group means, so it is name is the ethyl acetoacetate. Here CH3 and here is the C2H5 means these are the unsymmetric compound. If these are same, it is a symmetric. If these group are different, these are the unsymmetric compound. See the next point. Preparation of EAA. The long form of EAA is the ethyl acetoacetate. Here, how the formation of ethyl acetoacetate. Here, two molecules of alpha hydrogen containing ester on base catalyzed condensation in presence of sodium ethoxide and the formation of beta ketoester is formation of beta ketoester or ethyl acetoacetate. This is the reaction is also called as the Claisen condensation reaction. Here see example CH3 C double bond O C2H5. These are the ethyl acetate. Here is also CH3 C double bond O C2H5. Here both molecules are used same. These are ethyl acetate. In the presence of base means here is used the base C2H5O Na. Sodium ethoxide is the base and these are condensed and formation of the CH3 C double bond O CH2 C double bond O C2H5 and the name of this compound is ethyl acetoacetate. Its name is EAA. Ethyl acetoacetate formation. Here is use the ethyl acetate in presence of base. Base is used here C2H5. Here is the condensation reaction and the name of this reaction is a Claisen condensation reaction. See the next point is you have tried this type of also reaction, both are same. This reaction and this reaction is same. The next point is mechanism. Here is the formation of ethyl acetoacetate from ethyl acetate. By step procedure, see here how the formation of ethyl acetoacetate. In the first step, here is sodium ethoxide is attack on the first molecule of ethyl acetate. See here the reaction C2H5O minus Na plus. Actually, this O minus extract the protons from ethyl acetate. Here is CH2 group is a acidic group due to the presence of this C double bond O C2H5 electron withdrawing group and this is the base. Base is abstract the proton and formation of alcohol here C2H5OH and this gives here the attack on this CH2 here becomes a negative charge or it is a ester anions. Anions means negative charge on the molecule. CH2 minus C double bond O C2H5. C double bond O C2H5 is a ester and it is CH2 minus ion means anion. Ester anion formation. It is the intermediate product. In the next step, this ester anion attacks the carbonyl group of a second molecule of ethyl acetate. In preparation, we have to use here two molecules of the ethyl acetate. See, the next reaction here is the use the other or second molecules of the ethyl acetate, and this is the first molecule of the ethyl acetate. Here is formation of anion. This attack on the carbonyl group of second. This is the carbonyl group. C double bond O means carbonyl group. And here show the direction of arrow is from negative to positive. Here is electron deficiency. So this attack on this carbon, and this carbon oxygen double bond gives attack on this oxygen, and this type of intermediate product is formation. Here is the CH3 C double bond O. Here is the CH3 C double bond O is converted into single bond and O minus ion, and this OC2H written here OC2H, and this CH2 C double bond O C2H C2H5 is attached to this carbon, this carbonyl group. In this intermediate is formation. In the next step or third step, ethoxide ion is removed or eliminated. How it is eliminated? Here the negative sign on oxygen means here is the presence of electron. This gives attack on this carbon, and here is formation of carbon oxygen double bond, and this OC2H5 is removed, and finally the formation of CH3 C double bond O CH2 C double bond O. Here COC2H5. This is the CH3 C double bond O CH2 C double bond O OC2H5. The name of this compound is ethyl acetoacetate or EAA. And last remove the O minus C2H5 or C2H5 O minus ion. Or base is remove actually here. Starting using base, here the remove C2H5 ethoxide ion, and the formation of the main product is CH3 C double bond O CH2 C double bond O C2H5. This type of the synthesis of ethyl acetoacetate or preparation of ethyl acetate from ethyl acetate. This is the condensation reaction. The name of this reaction is a Claisen condensation reaction. This type of mechanism we have to study. Okay, it is clear. Thank you. This is the second type of mechanism. These both are same. Okay, thank you.